Placing windows in Google SketchUp is a straightforward process that involves using pre-made components or creating custom openings. Here's a step-by-step guide on how to do it. Placing windows in Google SketchUp. Option 1. Using pre-made window components. This is the easiest and fastest method. Open the 3D Warehouse. Go to Window a 3D Warehouse, Get Models, or click the 3D Warehouse icon. Search for Windows and browse different types: casement, sliding, bay, etc. Download and place the window. Select a window model and click Download. Choose Yes to load directly into your model. Click to place the window on a wall face. Use the Move tool, M, to position it properly. Adjust size and orientation. Use the Scale tool, S, to resize if needed. Use the Rotate tool, Q, to adjust orientation. Option 2, manually creating window openings. This is helpful if you're customizing window dimensions or style. Draw the wall. Use the Rectangle tool, R, to draw a face for your wall. Use Push/Pull tool, P, to extrude the wall to the desired thickness. Draw the window opening. On the wall face, use the Rectangle tool to draw where the window will go. Use Tape Measure tool, T, to help position the rectangle accurately. Cut the opening. Use the Push/Pull tool, P, to push the rectangle inward until it cuts through the wall. Add window frame or glass, optional. Use the Offset tool, F, to create a frame around the opening. Draw a rectangle over the opening for glass and use the Paint Bucket tool, B, to apply a transparent material. White heavy checkmark tips. Group your windows separately to avoid merging them with the wall. Use guides and inference locking, hold Shift, to align windows accurately. Make components of custom windows to reuse them easily. Let me know if you'd like instructions for SketchUp Web, adding mullions or sills, or making parametric dynamic windows. In construction, windows play a critical role in providing natural light, ventilation, aesthetics, and insulation. They come in a variety of types, each suited to specific functions, architectural styles, and building requirements. Below is an overview of the most common types of windows used in construction. 1. Casement windows. Description: hinged at the sides and open outward like a door. Advantages: excellent ventilation, tight seal for energy efficiency. Common use: residential homes, especially in areas with good outdoor views. 2. Sliding windows. Description: operate by sliding horizontally along a track. Advantages: easy to use, space-saving, ideal for wide openings. Common use: modern homes, patios, and basements. 3. Double-hung and single-hung windows. Double-hung, both top and bottom sashes slide vertically. Single-hung, only the bottom sash moves, the top is fixed. Advantages: good ventilation control, easy to clean, especially double-hung. Common use: traditional style homes, historical renovations. 4. Awning windows. Description: hinged at the top and open outward. Advantages: can remain open during rain, good ventilation. Common use: bathrooms, basements, and over kitchen sinks. 5. Hopper windows. Description: hinged at the bottom and open inward. Advantages: great for ventilation and tight sealing. Common use: basements and small rooms. 6. Bay and bow windows. Bay windows, combination of 3 windows angled outward. Bow windows, a curved combination of 4 or more windows. Advantages: create additional interior space, allow panoramic views. Common use: living rooms, reading nooks, and front facades. 7. Fixed or picture windows. Description: do not open, designed to let in light and provide views. Advantages: energy efficient, aesthetically pleasing. Common use: living rooms, stairwells, architectural features. 8. Skylight and roof windows. Skylight, installed in the roof for natural light. Roof window. Like skylights, but often operable. Advantages: maximize natural lighting, save wall space. Common use: attics, lofts, bathrooms, and kitchens. 9. Louvered or jalousie windows. Description: consist of parallel glass or acrylic slats that open like blinds. Advantages: good airflow control. Common use: tropical climates, sunrooms, porches. 10. Clerestory windows. Description: installed high on walls, often near the roofline. Advantages: provide natural light without compromising privacy. Common use: large halls, modern and industrial-style homes. 11. Tilt and turn windows. Description: can tilt inward at the top or swing in like a door. Advantages: versatile, easy to clean, secure. Common use: European-style constructions and modern buildings. Each window type offers different benefits in terms of energy efficiency, ventilation, aesthetics, and functionality. Choosing the right type depends on the building's purpose, climate, and architectural design. Foundation in construction. A foundation is the structural base that supports a building or other construction project. It is one of the most critical components in construction, as it distributes the load of the structure to the ground, ensuring stability, strength, and safety over time. A well-designed and properly constructed foundation prevents excessive settlement, structural damage, and eventual failure of the building. Functions of a foundation. Load distribution transfers the weight of the structure and its occupants to the underlying soil or rock. Stability anchors the structure, resisting lateral forces such as wind, earthquakes, or floods. Prevention of settlement reduces uneven settlement that could cause cracks or tilting. Moisture barrier acts as a barrier to moisture from the ground, protecting the structure from dampness and mold. Frost protection. In colder climates, it extends below the frost line to prevent frost heaving. Types of foundations. 1. Shallow foundations. Used when the soil close to the surface can support the load of the structure. Spread footing foundation, a wide base that spreads the load, used for individual columns or walls. Mat or raft foundation, a large concrete slab covering the entire building footprint, used when loads are heavy or soil is weak. Slab on grade, a single concrete slab poured at ground level, often used in residential buildings. 2. Deep foundations. Used when the surface soil is weak or unstable, requiring the load to be transferred to deeper, more stable soil layers. Pile foundation, long, slender columns driven deep into the ground. Pier foundation, large cylindrical columns placed deep into the ground to support heavy loads. Caisson foundation, watertight retaining structures used in underwater or bridge construction. Factors affecting foundation design. Soil type. Different soils have different bearing capacities and drainage properties. Load requirements. The total load, dead, live, and environmental, affects the size and type of foundation. Water table level. High water tables can affect stability and construction techniques. Climate. Freeze-thaw cycles, rainfall, and temperature extremes influence foundation design. Building type and usage. Industrial buildings may require deeper or more reinforced foundations than residential structures. Construction process of foundations. Site investigation and soil testing. Excavation. Formwork setup. Reinforcement placement. Concrete pouring. Curing. Backfilling and compaction. Conclusion. The foundation is the invisible but vital backbone of any structure. It ensures durability, safety, and performance, and must be designed and constructed with careful attention to soil conditions, load requirements, and environmental factors. A strong foundation is not just about concrete and steel, it is about understanding the science of soil, structure, and stability.